study was conducted to determine the proportion of people who dream in black and white instead of color. Among 297 people over the age of 55, 75 dream in black and white, and among 284 people under the age of 25, 10 dream in black and white. Use a 0.01 significance level to test the claim that the proportion of people over 55 who dream in black and white is greater than the proportion for those under 25. Completes part A through C below. Okay, so let's first create a hypothesis test. So let's go and state HO and H1, the null and alternative. Okay, so there's a lot going on here. First, recognize we are looking at two proportions, right? So we have 75 over 297 versus 10 over 284. Don't let the age in there make that one of the values of your proportion. That's what we're looking at, right? So it says here also, consider the first sample, so P1, to be people over the age of 55. And what are we looking for? We're looking for the claim that for people over 55 who dream in black and white is greater than. So P1 is greater than P2. That's an alternative hypothesis, which falls under D. The null in this class is always equal. Always equal. Okay. Identify the test statistic. We are not going to do these by hand. I'm not sure if the view example shows you the by hand method, but we are going to eschew the hand method, and we are going to use technology. I had to check, and of course they do the by hand method, where they're finding out the z-values and test statistics and all that. We are not going to do that, okay? So I'm going to go to question help and click StatCrunch. And that's one reason I'm making these videos, is because at this time they don't have specific problems related to using the technology. Okay, so we're going to go to Stat, Proportion Stat, which you might not be able to see. Let me lift this up. Proportion Stats, we have two samples now, and we have summary data. Okay, so sample 1. Remember, sample 1 is the people that are over 55. And it says 297, 75 driven black and white. So our number of successes, and the success in this case is just what we're looking at. We're looking at people, we're comparing people, black and white teaching, dreaming that is. So we have 75, and observations, there were 297. Now sample 2. It says out of 284 people, 10 of them dream in black and white. So number of successes for sample 2 is 10 out of a total of 284. And we've already set the null alternative, and they write it slightly differently. So they have P1 minus P2 equals 0. They've gone ahead and subtracted P2 from both sides. So let me pull this back down. So imagine me subtracting P2. We'll have P1 minus P2 equals 0. And then subtract P2. We'll have P1 minus P2 is greater than 0. So P1 minus P2 is greater than 0. And then click Compute. And here we go. So let's see what it asks for. And the test statistic is 7.4, is it around the two places? So 7.41. Now identify the p-value. So with a test statistic this big, so 7 standard deviations above the mean, this is going to be a very small p-value. And according to StatCrunch, it's just less than 0.0001. So to 3 places, it's just going to be 0.000. It should take that. There we go. We could have just put 0 too, I think. Okay, what is the conclusion based on this hypothesis? I always like to look back at the printout. So notice what we have in here. What we have happened here. So again, we don't want to lose sight of what we're comparing. So we're comparing this first count and I've gone ahead and put in the calculator, 75 over 297, that proportion, which is about 25%, and those are people that are over 55, to the proportion of people that are under 25, which was about 3.5%. We'll say 4%. So how likely is it for a difference that large to occur by chance? And the sample difference according to StatCrunch is about 22%, which if I just subtract those two values, that's all I'm doing there, and that is right. So intuitively, it seems that this difference is much too large to have happened by chance. So I'm not surprised at all by this large z statistic and a very small p-value. So I always go back and look at just naturally what would we think before we kind of get technical here. So here the p-value is less than the alpha level. So when we got a super small p-values, and what is that threshold? It's defined by alpha, also called the significance level. So we're going to reject the null hypothesis. Look back at the null. The null says that they're equal. Well, there's no way they're going to, there's a way. It's very unlikely these two are equal. There is strong evidence or sufficient evidence here. Sometimes I'll even qualify that with a test statistic this large to support the claim the proportion of people over 55 who dream in black and white is greater than the proportion of those under 25. Okay, now let's test the claim by constructing an appropriate confidence interval. And they're choosing a 98%, which is fine. We have technology. We don't care what they ask us to do. We can do it. So back in this, I'm going to go up to Options in the StatCrunch and click Edit. And there is a confidence level option. And let's change this to 0.98. And press Compute. And so here we go. Very similar output, right? Except when it comes to the lower limit and upper limit. And it says to round to 3 decimal places. So we're going to have 0.153 as the lower and 0.281. Long problem, eh? Okay, so what is the conclusion based on the confidence interval? So let's look at this confidence interval. It's saying this difference is in between about, let's convert these to percent. Sometimes that makes a little bit more sense. 15% and 28%. So the confidence interval does not include 0, does it? It appears that the two proportions, when it says two proportions, it's talking about the P1 and P2, the proportion of people over 55 and the proportion of people that are under 25. It appears they are not equal, right? And we already said that. We already said we're rejecting the fact that they are equal. Because the confidence interval limits include, here, in this case, it's only positive values. It appears the proportion of people over 55 who dream in black and white is greater than the proportion of those under 25. In fact, what is that difference? Between 15 and 28% greater. That's huge. Okay, so an explanation for the result. So we often want to know, well, why is that? Why do people who are over 55 dream in black and white, and people who are under 25 don't dream in black and white as often? So what are our choices here? Can these results be used to verify this explanation that people 55 and over grew up exposed to media that was displayed in black and white? So yes or no? So no, we can't really verify why there is a difference. All we're detecting with these statistical tests is that there is a difference. So here's a no. No, the result speaks to possible differences between proportion who dream in black and white, but the results are not statistically significant enough. No, that's definitely not true. I mean, these are very statistically significant, right? It's got a p-value of 0. It doesn't get much more significant than that. But no matter how statistically significant it is, we still cannot tease out the reason for that explanation. And so D is our only choice here. Okay, so I hope that helps. That was a long problem to go through. Hopefully worth it. Okay, I want to show you how to do the same test on the TI-83 or 84. You're going to press Stat, Test, and this is 2 proportions z-test. So number 6. We're going to put in, we'll just go ahead and use what they used. The number 1 was over the age of 55. And so our X is 75. And our N is 297. And then for the second sample, people under the age of 25, we have 10 people who dreamed in black and white out of a total of 284. And we're saying that P1 is greater than P2. Calculate. And we get the same Z value, 7.4. And look at our P-value. This is 6.41 times 10 to the negative 14. Don't you dare put P-value of 6.4. Whenever I see that, I know we don't really know what a P-value is. Remember, the P-value is a probability, always between 0 and 1. So this is like 13 zeros and then 6. So that is a very, very small number. I like the way the TI gives the output here. It tells me the P hats of sample 1 and sample 2, 25% and 3.5%. Same thing we got when I did it manually. So I hope that helps. Oh, and let's go ahead and run a confidence interval. You'll see we get the same thing. So stat, test, we're going to go to 2 prop z interval, which is the B. Nice thing here is it automatically repopulates my values there for X and N, and let's change the confidence level to 98. Calculate, and we had exactly the same values. Well, actually slightly different, 0.153 and 0.281. The computer should take that. Let me make sure I pop that in right. Two prop z interval, 98.